Hello students, today we will learn the topic voltage multiplier circuits. In this session, we will cover the following contents. We will first understand the definition of the voltage doubler and the multiplier circuits. Then we study the different types of the voltage multiplier circuits like voltage tripler and voltage quadrupler. Then we will see the working of the voltage doubler circuit. There are two types of voltage doubler, half wave voltage doubler and the full wave voltage doubler. Then we will learn the working of the voltage multiplier circuit, that is voltage tripler multiplier circuit and the voltage quadrupler multiplier circuits. Let's start with the voltage multiplier circuit. Voltage multiplier circuit is a circuit which will provide the output voltage and time multiplication of the input peak voltage when n is equals to 2, then voltage multiplier is said to be as a voltage doubler. N is equals to 3, voltage tripler, and n is equals to 4 is voltage quadrupler. So it will keep the transformer turns ratio unchanged. Basically, any voltage multiplier consists of the ideal diodes and the capacitors combination to step up the output of the rectified output voltage. So let's define the voltage doubler. So voltage doubler is a circuit which provides the 2 times of the input peak voltage at the output, keeping the transformer turns ratio unchanged. Basically, there are two types of voltage doubler we have. One is half wave voltage doubler and another is a full wave voltage doubler. Let's discuss the voltage multiplier circuit. Voltage multiplier circuit are of two categories. One is voltage tripler multiplier circuit and another is voltage quadrupler multiplier circuit. So voltage tripler multiplier circuit is the circuit which provides the 3 times of the input peak voltage at the output by keeping the transformer turns ratio unchanged. Again, it is made up of the diodes and the capacitors. Another category of the voltage multiplier is the voltage quadrupler multiplier circuit, which will provide the 4 times of the input voltage of the at the output by keeping the transformer ratio unchanged. Please, the circuit which is used for making the voltage tripler and voltage quadrupler is common. Only the terminal output is changed with the same common circuit. So let's start with the different types of the voltage multiplier circuits. Voltage multiplier are of different types. It may be classified as voltage doubler, voltage tripler and the voltage quadrupler. Voltage doubler may be further classified as the half wave voltage doubler, which is the circuit diagram given here, and full wave voltage doubler. This is the circuit diagram for the full wave voltage doubler. The circuit for the voltage tripler and the voltage quadrupler is common, which is shown here. The assumption which I will take for understanding the working of the voltage multiplier is that all the diodes which I will use to make these circuits are ideal in nature, and the capacitors which I am using in these circuits are having a very high time constant, so that they will restore the charge for the particular number of the cycles. Let's discuss the basic circuit diagram of the half wave voltage doubler circuit. This is the circuit diagram for the half wave voltage doubler circuit, in which we have the transformer for which will supply the AC input supply to this circuit. These are the capacitors C1 and C2, and there are two diodes D1 and D2 which are ideal in nature, and we will take the output across this load resistance through this terminal. Let's discuss the working of the half wave voltage doubler. So this is the circuit diagram for the half wave voltage doubler. So when in the secondary, we have in the first positive half cycle, diode D1 will be in the forward bias state and diode D2 will be in the reverse bias state. So making the electrical equivalent circuit of this, when the diode D1 is in the on state, replace it by the short circuit, and diode D2 is in the off state or in the reverse bias condition, so it is replaced by the open circuit. Now apply the KVL in this loop in the clockwise direction. You will get the equation as plus Vm minus Vc1 minus 0 is equals to 0. Why it is 0? Because we have replaced the diode by the short circuit equivalent. So voltage across the diode is 0. So calculating the voltage across the capacitor as Vc1 is equals to Vm, means the capacitor C1 will be charged to the peak voltage, that is Vm, right? In the next negative half cycle, as soon as the voltage polarity across the secondary has been reversed, diode D2 will be in the forward bias state and diode D1 will be in the reverse bias state. Let's make the electrical equivalent circuit. Since the diode D2 is in the forward bias state or the on state, it is replaced by the short circuit, and diode D1 is in the reverse bias state or in the off state, so it is replaced by the open circuit. Just apply the KVL in the outer loop through the capacitor C2 and C1. you will get the voltage across the capacitor C2 as equals to 2 Vm. Now apply the KVL in the outer loop as plus VO plus Vc2 equals to 0, since Vc2 is charged with the voltage twice of the input peak voltage Vm. So VO is equals to minus of 2 Vm. So as you can see, the magnitude across the output terminal is doubled. So that's why it is called as the half wave voltage doubler. Let's discuss the next type of the voltage doubler, that is full wave voltage doubler. So this is the basic circuit diagram of the full wave voltage doubler, in which we have the AC supply through this transformer. We have the two diodes D1 and D2, and we have the two capacitors C1 and C2, and this is the load resistance across which we will take the output. Basically, you are taking the output across the capacitors C1 and C2. So let's discuss the working of the full wave voltage doubler. In the first positive half cycle, diode D1 will be in the on state and diode D2 will be in the off state. So let's make the electrical equivalent circuit diagram in which the on state model is replaced by the short circuit. Diode D1 is short circuited, while D2 is in the reverse bias state, so it will be replaced by the open circuit. So just apply the KVL through the capacitor C1. You will get that equation as plus Vm minus of Vc1 equals to 0. So you will get the voltage across the capacitor C1 as equals to the input peak voltage, that is Vm. Right? Means the capacitor C1, due to the high time constant, will hold this voltage peak voltage Vm for the next negative half cycle. In the next negative half cycle, as soon as the polarity across the secondary has been reversed, diode D1 will be reverse biased and diode D2 will be forward biased. So just make the electrical equivalent. This diode which is in the off state will be replaced by the open circuit, and this diode D2 will be replaced by the short circuit. Just apply the KVL through the capacitor C2 and D2. There will be no current flowing through this diode D1. So you will get the equation as plus Vm minus Vc2 equals to 0. So the capacitor voltage will be charged to input peak voltage Vm. Note that due to the very high time constant of the capacitors, they will hold the voltage sufficiently for the next positive half cycle. The output voltage for the full wave voltage doubler can be given from this circuit arrangement. We have seen, due to the high time constant, both the capacitors C1 and C2 will hold the input peak voltage Vm, that is Vc1 and Vc2, they are equals to Vm. So just apply the KVL in this highlighted region to calculate the output voltage. So you will get the equation as VO is equals to Vc1 plus Vc2, that is VO is equals to twice of Vm. Right, so you will see that your voltage appearing at the output terminal is twice the input peak voltage. That's why it is called as the voltage doubler. Right, so the time constant for these two capacitors are very high, which will hold the voltages for sufficiently for the next cycles. And we have seen that the series combination of the C1 and C2 will give me the poor filtering action. Let's understand the voltage multiplier circuit. They are of basically two types: voltage tripler and the voltage quadrupler. Basically, the circuit for understanding the working of the both tripler and quadrupler is common. So basic circuit diagram can be given as here, in which we have the AC input supply which is given through the transformer, and we have the four capacitors C1, C2, C3 and C4, which has the very high time constants, and we have the four diodes D1, D2, D3 and D4 arranged in this fashion, which are treated as the ideal diode. So this is the common circuit which will be used for understanding the tripler and quadrupler, because if we take the output across the capacitors C1 and C3, you will get the tripler output, and when you will take the output across the C2 and C4, you will get the quadrupler output. Let's understand the working of the voltage multiplier circuit step by step. So in step 1, this is the voltage multiplier circuit we have, in which in the first positive half cycle, diode D1 will be in the forward bias state or in the on state, and rest of the diodes D2, D3 and D4 are in the off state. Initially, I am assuming all the capacitors are uncharged and they are the very high time constant. So making the electrical equivalent in this step, replacing the on state diode D1 with the short circuit, and diode D2, D3, D4 which are in the off state will be replaced by the open circuit. So just apply the KVL in the clockwise direction. You will get the voltage across the capacitor Vc1 as the Vm. Right. So the capacitor C1 will hold the peak input voltage, that is Vm. In the next negative half cycle, diode D2 will be in the on state, D1, D3, D4, they are in the off state. So making the electrical circuit, replace the diode D2 with the short circuit and replace all the other three diodes with the open circuit model, that is off state model. So now apply the KVL in this anti-clockwise direction via C2, D2 and C1. You will get the equation as plus Vm minus Vc2 plus Vc1 equals to 0. Since the capacitor C1 will hold the voltage of input peak voltage, that is Vm, in the first positive half cycle. So replace Vc1 by the Vm. You will get the capacitor voltage across the C2 as twice of the Vm. So C2 will hold the voltage that is twice of Vm for the next two cycles. In the second positive half cycle, we have seen from the previous two cycles that capacitor C1 hold the voltage maximum Vm and C2 has hold the voltage that is equals to twice of Vm. So with this situation, only diode D3 will be in the on state, while rest of the diode D1, D2 and D4, they are in the off state. So making the electrical circuit, replace the diode D3 with the short circuited and diode D1, D2 and D4, replace it by the off switch off state, that is open circuit, right? So just apply the KVL via C1, C3, diode D3 and the C2. Since these are in the on state, diode D1 is in the on state and diode D2, D1 and D4, they are in the off state. So this KVL equation will give me as plus Vm minus of Vc1 minus of Vc3 plus Vc2 equals to 0. So replace the substitute the required value as Vc1 as Vm, Vc2 as a 2Vm. You will calculate the voltage across the capacitor C3, Vc3 as twice of Vm. So the capacitor C3 will hold the voltage twice of Vm for the next cycle. So in the second half negative cycle, the capacitor C1 holds the voltage Vm, C2 will hold the voltage of 2 twice of Vm, C3 will hold the voltage of twice of Vm, as we have seen in the previously 3 cycles. So this situation makes the diode D4 in the on state or in the forward bias state, while rest of the diodes are in the reverse bias states. So they are treated in the as a off switch. So making the electrical equivalent circuit for this situation, replace the diode D4 with the short circuited and rest D1, D2, D3 replace it by the open circuit or the off state model. So just apply the KVL via input supply C2, C4, diode D4, C3 and C1. As you can see, only the diode D1 is in the on state and while D1, D2, D3 they are in the off state. So just applying the KVL, you will get the equation as plus Vm minus of Vc2 minus of Vc4 plus Vc3 plus Vc1 equals to 0. So just substitute the value Vc1 as Vm, Vc2 as twice of Vm, Vc3 as twice of Vm. So you will get the voltage across the capacitor C4 as the twice of Vm, that is Vc4 is equals to twice of Vm, means capacitor will be charged with the twice of the peak input voltage, right? So this is the step after the 2 complete cycle. Now let's take the output of the voltage multiplier. As we already have discussed that this is the common circuit for the voltage tripler and quadrupler. So let's discuss the output for the voltage tripler multiplier circuit. So voltage tripler output is taken across the capacitor C1 and the C3 as shown in this figure. So as in the highlighted region, you can see when you apply the KVL, you will get the equation as VO minus Vc1 minus Vc3 equals to 0. So replace the Vc1 by the Vm and Vc3 by the twice of Vm. You will get the output voltage VO is equals to 3 times of the Vm. So you can see the voltage which is available at the output of this capacitor C1 and C3 is 3 times of the input peak voltage. That's why it is called as the output of the voltage tripler multiplier circuit, right? So before discussing the output of the quadrupler, let's revise the circuit diagram for the voltage quadrupler multiplier circuit. This is the same circuit diagram which we have analyzed previously in previous slides. Only the difference is that in the case of the voltage quadrupler, you will take the output across the capacitor C2 and C4 as shown in this figure. So in this voltage quadrupler circuit, this is the AC transformer. These are the four capacitors with the high time constants, and these are the four diodes, diode D1, D2, D3, which are in ideal in nature. So we will take the output across the capacitors C2 and C4. This is how the output is highlighted. Let's discuss the final output of the voltage quadrupler multiplier circuit. So this is the circuit arrangement. Already we have seen, we did the analysis for this circuit, and we have seen that the capacitor C1 is charged with the hold the voltage Vm. Capacitor C3 will hold the voltage of 2 Vm with the polarity plus and minus. Capacitors C2 and C4, they also hold the voltage 2 Vm with the corresponding polarity. So the output voltage can be given as by applying the KVL, by finding the voltage across these capacitor terminal, that is C2 and C4, as Vu minus Vc2 minus Vc4 equals to 0. Both replace the value Vc2 and Vc4 as by 2 Vm. So you will get the output voltage as 4 times of the input peak voltage, that is 4 times of Vm. So this is how the voltage is quadrupled. That's why it is called as the voltage quadrupler multiplier circuit. So this is all about the voltage multiplier circuit. Hope you learned something in this session. Thank you very much.